Welcome to Cambridge IGCSE Physics, Lesson 13.1, Understanding Pressure. Today we explore how force spreads over area and learn to calculate pressure using the fundamental equation P equals F over A. This core concept applies throughout physics and engineering. Let's examine our learning objectives for today. By the end of this lesson, you will be able to define pressure as force per unit area, understanding that pressure measures how concentrated a force is. Recall and use the equation P equals F over A, where P is pressure, F is force, and A is area. Calculate pressure in simple situations using proper SI units and significant figures. These objectives align with assessment. Objective 1 for knowledge, Assessment Objective 2 for calculations, and Assessment Objective 3 for practical applications. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, pressure, which means force acting per unit area. This tells us how concentrated or spread out a force is over a surface. Second, Pascal, pronounced Pascal, which is the SI unit for pressure, equal to 1 Newton per square metre. Third, force per unit area, which is the fundamental definition of pressure. It describes how much force acts on each square metre of surface. Understanding these terms precisely is crucial for calculations and explanations. Let's explore our first core concept. The fundamental principle states that pressure measures force concentration, how much force acts on each unit of area. This means the same force creates different pressures depending on the area it acts upon. The definition is, pressure is the force acting perpendicular to a surface per unit area. Mathematically, we express this as P equals F over A, where P represents pressure measured in pascals, F represents force measured in newtons, and A represents area measured in square meters. The diagram illustrates force arrows acting perpendicular to a surface over area A. Notice how the force spreads across the entire area. This principle is fundamental because it explains why sharp objects penetrate easily and why large areas reduce pressure. Now we examine the experimental method. This follows Cambridge IGCSE standards. The apparatus needed includes a Newton meter to measure force in newtons, a ruler to measure dimensions in meters, and blocks of known area to provide the surface. The method consists of these steps. First, measure the force using the Newton meter, ensuring the force acts perpendicular to the surface. Second, calculate the area by measuring length and width, then multiplying them together. Third, apply the formula P equals F over A to find pressure. Safety is paramount. The hazards include applying excessive force, which could damage equipment. Therefore, you must handle apparatus carefully and apply force gradually. The diagram shows the setup with the Newton meter measuring upward force on the block and rulers measuring the contact area. Let's work through our first example. The problem states a force of 20 newtons acts on an area of 4.0 square meters. Calculate the pressure. We are given force F equals 20 newtons and area A equals 4.0 square meters. We need to find pressure P in pascals. Step 1. Write the equation. We use the pressure formula, which is P equals F over A, where P is pressure, F is force, and A is area. Step 2. Substitute the values. We write P equals 20 newtons divided by 4.0 square meters. Step 3. Calculate. 20 divided by 4.0 equals 5.0. Step 4. State the answer. The result is 5.0 pascals to two significant figures, with units of pascals which equal newtons per square metre. Example 2 applies the same principle differently. The problem is, compare pressure from different areas when the same force acts on each. The data shows force of 100 newtons acting on two different areas, 1.0 square metres and 0.5 square metres. Now we analyse. First, calculate pressure for 1.0 square metres. Using P equals F over A, we get P equals 100 divided by 1.0, which equals 100 pascals. Second, calculate pressure for 0.5 square metres. We get P equals 100 divided by 0.5, which equals 200 pascals. Third, compare results. The smaller area produces higher pressure. Fourth, state the relationship. Pressure is inversely proportional to area. The graph shows this inverse relationship clearly. As area decreases, pressure increases proportionally. Mathematical skills are crucial in physics. Let's examine 3 key skills. First, equation rearrangement. When we need to find a different variable, we rearrange algebraically, starting with P equals F over A, where P is pressure in pascals, F is force in newtons, and A is area in square meters. To find force F, we multiply both sides by A, giving F equals P times A. To find area A, we divide both sides by P, giving A equals F over P. Second, unit conversion. To convert from square centimeters to square meters, we divide by 10,000. Because 1 meter equals 100 centimeters, so 1 square meter equals 10,000 square centimeters. For example, 50 square centimeters equals 0.0050 square meters. Third, uncertainty analysis. Percentage uncertainty equals uncertainty divided by measurement, multiplied by 100%. This quantifies measurement precision and helps evaluate result reliability. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, calculate pressure when 15 newtons acts on 3.0 square meters. Use the formula P equals F over A directly. Question 2 is intermediate. It states, find force needed for 200 pascals over 0.25 square meters. This requires you to rearrange the equation to F equals P times A. Question 3 is advanced. The question is, compare pressures when 80 newtons acts on 2.0 square meters versus 40 newtons on 0.5 square meters. This tests your analytical skills by requiring 2 calculations and comparison. For all questions, remember to show you're working clearly, include units in every step, and check your answers make physical sense. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how today's concepts apply in practice. In technology, hydraulic systems use pressure to multiply force. Car brakes and construction equipment apply small forces over small areas to create large forces over large areas using Pascal's principle. In medicine, blood pressure monitoring measures the pressure blood exerts on artery walls, providing crucial health information about cardiovascular function. In engineering, building foundations distribute the building's weight over large areas to reduce pressure on the ground, preventing structural failure. These applications show why physics matters. Career-wise, physics knowledge leads to many professions. Mechanical engineering designs, hydraulic systems, biomedical technology develops pressure monitoring devices, and construction design ensures safe load distribution. The concepts you learn today become tomorrow's innovations. Let's review the solutions. For question 1, the answer is 5.0 pascals. Using P equals F over A, we substitute 15 newtons divided by 3.0 square meters, giving 5.0 pascals. This is reasonable for everyday pressures. For question 2, we rearrange to find force. F equals P times A, so F equals 200 pascals times 0.25 square meters, giving 50 newtons. This makes sense. Higher pressure over smaller area still requires significant force. For question 3, we calculate both pressures. Case 1 gives 40 pascals, case 2 gives 80 pascals. Notice case 2 has half the force, but quarter the area, resulting in double the pressure. Now, exam success tips. First, always show you're working. Even if the final answer is wrong, you earn marks for correct method and formula use. Second, include units in every step of calculation. This prevents unit errors and shows understanding. Third, check if your answer is reasonable. If you calculate pressure of 1 million pascals for a person standing, something is wrong. Fourth, read questions carefully. Identify exactly what the question asks for. Pressure, force, or area, or. Let's summarize today's lesson. The key points to remember are: first, the definition. Pressure is force per unit area, measuring how concentrated a force is over a surface. This fundamental concept explains many everyday phenomena, from sharp knives to building foundations. Second, the formula P equals F over A, where P is pressure in pascals, F is force in newtons, and A is area in square meters. Always use SI units for consistency and accuracy. Third, the relationship. Pressure is inversely proportional to area, meaning smaller areas create higher pressures for the same force. For further study, review pressure formula rearrangements to solve for force or area. Practice unit conversions, especially square centimetres to square metres. The next lesson covers pressure in fluids, which builds on today's work by exploring how pressure varies with depth and density. Ensure you understand today's basic pressure concept before moving to fluid pressure. Remember, physics builds systematically. Each lesson connects to create deeper understanding.